Good morning, everyone. Today we're going to talk about scientific notation. In science, we come across both very large and very small numbers. Avogadro's number is an example. As you can see, it is so large that writing it as part of our work on a problem would be difficult, just for space reasons. And so scientific notation is a format for writing numbers that allows us to write very large and very small numbers in a small amount of space. But it also allows us to be very clear about the number of significant figures that are in a number like Avogadro's. So it exists to form two needs. But what is scientific notation? So really, scientific notation is really just a form of factoring. And the thing that we are factoring is the significant figures. So we factor out the significant figures and then write them separately from all of the non-significant digits. So what do I mean by that? Let's look at some examples. Here we have 602,000. And in this case, the significant figures are the 6, the 2, and the 0 trapped between them. So we have 3 significant figures. And I want to factor them out of this number. And when I do so, I want to make sure that I factor them out as a number between 1 and 10. And we'll talk more about why I want to do it that way in just a minute. But for now, what that means is I'm going to factor out 6.02, which leaves us with 100,000. Notice that 6.02 also has 3 sig figs, just like the original format of this number. So we've taken all of the significant figures and factored them out to the left, leaving behind on the right a nice, relatively simple, though kind of long number of 100,000. Looking at that 100,000, it has a 1, and it has 1, 2, 3, 4, 5 zeros behind that 1. So instead of continuing to write 100,000, I'm going to collapse that number down into the more concise 10 to the 5th power. And I'm going to bring down my 6.02. So now, instead of writing 602,000, I can write 6.02 times 10 to the 5th. Now this number is not extremely large, so we don't save a whole lot of space yet using the scientific notation format. However, it is more helpful for practice and explanation. Okay, so if I want to take 602,000 and write that in scientific notation, I would write it as 6.02 times 10 to the 5th power. Let's look at another example that will help us to understand why we always factor out the significant figures as a number between 1 and 10. Here I have 710 million, and as it is currently written, it has 2 significant figures in it, the 7 and the 10. And none of these zeros are significant because they are to the left of the decimal, so they don't meet the right of the decimal requirement in order to be a significant zero. But let's say that I have been tasked with writing this number so that it has 3 significant figures. Say that I have been tasked with writing this number so that it has 3 significant figures. There's a problem, because I literally cannot write this number in standard format so that it has 3 significant figures. So instead, I have to write this number in scientific notation in order to do it with 3 sig figs. So I'm going to factor out the 7, the 10, and the first 0 because I want that first 0 to be significant. And when I factor them out as a number between 1 and 10, in this case 7.10, now I suddenly have a number that has those 3 sig figs that I was required to write with. Because now this 0 is to the right of the number and to the right of the decimal. And this is why we always factor out our significant figures as a number between 1 and 10, so that the sig figs always come out correctly. When we factor out our significant figures, the other term, the other factor, is, of course, 100 million, which is kind of long to write. So before we can say that we're done, we're going to need to collapse these non-significant digits into a power of 10. So again, I'm going to count the zeros. 1, 2, 3, 4, 5, 6, 7, 8. And so I'm going to write this as 10 to the 8th power, and then bring down my significant figures. So here would be my final answer for this task, 7.10 times 10 to the 8th. And so here I have my 710 million, but now I have written it with 3 significant figures, like it said to do so. So that goes back to this idea that one reason that we use scientific notation is to clarify the number of significant figures in these numbers. So far, both of our examples have been large numbers. Now we're going to turn to looking at small numbers. And 0.003 is not terribly small, but it will allow us to get started with a nice example. So just like before, I'm going to factor out my significant figures. In this case, there's only one significant figure, and it is that 3. So I'm going to factor that out as 3. And 3 is between 1 and 10, so I'm all set to just leave that as 3. And then the other term in this factoring would be 0.001. Just like before, I'm going to take my non-significant digits and collapse them into a power of 10. And just like before, I'm going to count the number of zeros in order to do that. And also just like before, I'm going to start my counting in the ones place. But now I'm counting in the opposite direction, right? I'm now counting to the right. And because I'm counting zeros moving to the right, something slightly different happens when I go to write my power of 10. And that is that this becomes a negative power of 10, 10 to the negative 3rd power. Just like before, I bring my significant figures down, and I would have my final answer for this be 3 times 10 to the negative 3rd. And remember that this exponent is negative because our number is less than 1. It is a small number that we are writing using scientific notation. Okay? So whenever your number that you're writing is a small number, less than 1, your exponent is going to be negative. Nothing about the number is negative, just the exponent of 10. And that goes back to the fact that when we counted our zeros, we started in the ones place and counted right instead of counting left. Let's look at another even smaller example, 0.000006. This number also has one significant figure, just the 6. So when we factor out our significant figures, we're going to factor out that 6 all by itself because 6 is between 1 and 10. And then that leaves us with 0, 0, 0, 0, 0, 1 as our non-significant digits. Again, I'm going to start counting my zeros in the ones place, and then now I'm counting to the right. So remember that these exponents are going to be negative. 1, 2, 3, 4, 5, 6. So when I go to write my final answer, I'm going to write 6 times 10 to the negative 6th power, because there were 6 zeros. Okay? So here's our final answer for our last example. So today we talked about scientific notation, which is used to write very large or very small numbers. And our example of a very large number was Avogadro's number, which we will talk more about in the later in the semester. And it's also used to clarify the number of significant figures. And remember that we are really just factoring out the significant figures, and that when we factor out the significant figures, then they need to be written as a number between 1 and 10. And then when we collapse our non-significant figures into a power of 10, remember that if that number is larger than 1, the exponent of the 10 is going to be positive, and if the number is smaller than 1, the exponent of the 10 is going to be negative. Thank you very much, and have a nice day.